Good morning, all of you. In our last lecture, we discussed about the electric potential. Today, we are going to see that what is equipotential surface. Okay, so our today's topic is equipotential surface. Equipotential surface. As the name suggests, equipotential. It means means to say same, potential means to say electric potential. So the surface which carries electric potential same throughout whole the surface, that surface is called as a equipotential surface. For example, if we took a cube and say that on each and every point of the surface, each and every point on the surface of cube have the same value of potential V1, V2, V3, V4, as V1 is equal to V2 is equal to V3 is equal to V4. Then we will say that this surface is an equipotential surface. So there are few examples related to the equipotential surface. For example, if we have a point charge, then the equipotential surface related to this point. For a point charge, the equipotential surface is a spherical surface. For point charge, equipotential surface is a spherical surface. Second example, for a linearly distributed charge over a very thin wire, we will consider a cylindrical surface. And why this is the equipotential surface for the point charge? For example, let's see the practically demonstration that how we could consider that it is the equipotential surface for a point charge. As we can see that each and every point is placed same distance from the center of the sphere. This one is also r distance, this one is also r distance, this one is also r distance, this one is also r distance. And the charge is placed at the center of the sphere. So we can say that if all the points are at the same distance from the center and the charge is present at the center, so that the potential at every point will remain same because the distance from the charge is same. The distance from the charge is same, so that we can say that each and every point considered as a equipotential points. Everything, everywhere on the surface, the potential is same. Everywhere on the surface, the potential is same. For this example, here we can say that the surface, the curved surface, each and every point placed on the curved surface is placed on the same distance from the charge. Placed on the same distance from the charge. For example, this one is a pen, and let's consider that a charge is placed at the center of the line is going through the center, and on the line there will be charge, and we can say that the surface is called as a equipotential surface because each and every point is at the same distance from the center. It's the same distance from the center. That is why we can consider it as a equipotential surface. Is it clear to everyone? We can also relate the surfaces by the Gaussian surfaces. For a point charge, Gaussian surface is considered as a spherical surface or for the linearly distributed charge we considered Gaussian surface as a cylindrical. And one more thing, that there will be multiple surfaces. For example, if it is a point charge, then this sphere is also equipotential surface, and another sphere is also equipotential surface. Both surfaces are equipotential surface, but potential will be different on both the surface. For example, if on this surface each and every point considered as a V1 potential, then the potential on the second surface will be equal to V2. V1 will not be equal to V2, but the potential on each and every point on the surface will remain the same. मतलब क्या हुआ कि अगर हम concentric spheres लेते हैं, तो पहला वाला concentric sphere जो है उसके अंदर हर एक point पे potential जो है वो same रहेगा, और उसकी value consider की हमने V1. As it is, हमारा जो second sphere है उस पे भी each and every point पे potential की value V2 होगी. हर एक पॉइंट पे वैल्यू क्या होगी, सेम होगी, लेकिन पहले वाले स्फीयर के कंपैरिजन में वैल्यू जो है वो थोड़ी सी कम होगी. The value of V2 will be lesser as compared to V1. Why? Because the distance from the center is increasing, and as we know that if we increase the distance from the charge, then the potential also decreases. And the same way, there could be considered as a multiple concentric cylinder as an equipotential surface. Not a big deal. It's just a little example that multiple equipotential surfaces can also be possible. But the thing that all the surfaces should be concentric, and the potential will be different on the different surface. But on that same surface, each and every point considered as a same equipotential, same potential. Okay. Another example for another variations, that if a charge is something like dipole, there are combination of same charge having same magnitude separated by a small distance, and both have the opposite polarity. The equipotential surface for this kind of configuration will be something like this. We can justify this configuration as the distance increases as the distance increases between both the charges. What will going to happen? Both will become separated by a very large distance, and both will be considered as a single charge, and they will carry out spheres, concentric spheres. But as they are closer to each other, then a common region will be also there, which will also represent as equipotential surface. Next one is, what if there are two same polarity charges, positive or negative, then the equipotential surface will be also considered as a concentric spheres, but they do not have any common reason. So these are the equipotential surfaces for the configuration of charge. Okay. Another example for the equipotential surfaces, if the charge are distributed something like this, then the equipotential surface will be perpendicular plane through the distribution of charge. This one is the equipotential surface. This one is the equipotential surface. Okay. Now let's see a few characteristics based on the equipotential surface. Let's talk about few characteristics of the equipotential surface. Basically, these are the example for the equipotential surface for different configurations of the charges. Now let's see few characteristics of the equipotential surface. First one is, what will be the potential difference on the equipotential surface? Potential difference on equipotential surface. Potential difference on equipotential surface. What it means? It means कि मान लीजिए अगर हमारे पास कोई equipotential surface है for this charge q, if this sphere is a equipotential surface, then what will be the value of potential difference for point A and point B? As we know, the potential on equipotential surface remains same. Each and every point has the same potential on the equipotential surface. So we can say that potential difference del V or VB minus VA could be written as 0. Why? Because as we know, VB is equal to VA because both the points are placed on the equipotential surface, and if the points are on the equipotential surface, then the value of potential will be same for each and every point. Even if they we considered a point C, then also and we have to find out the potential difference between V and C, then del V is equal to VC minus VB also equal to 0 because VC is also equal to VB. Each and every point carried as a same potential on the equipotential surface. The next one is the work done moving a charge on the equipotential surface. The second characteristic is work done for moving a charge on equipotential surface. Work done for moving a charge on equipotential surface. ठीक है, देखते हैं. This is also a equipotential surface for Q charge. This is sphere as a equipotential surface, and we have to move a charge from A to B. We have to move a charge from A to B, and we have to find out that what will be the value of work done for moving a charge on equipotential surface from A to B. Let's see. As we know, del V is defined as work done on moving a charge from A to B per unit charge. If this one is a Q, then we could consider it as a Q dash. Q dash charge is moving from A to B on the equipotential surface. Okay, so the charge is moving from A to B, so the work done will be considered as WAB when we move a charge from A to B. Simple. And from the previous observations, we can say that del V is equal to VB minus VA is equal to 0. Why? Because we are working on the equipotential surface, and as we are working on the equipotential surface, then potential on each and every point of the equipotential surface will be considered as a 0 or same, as a same. So the difference will be considered as a 0. So let's see what is going to happen. If points are placed on the equipotential surface, then the potential will be same and the difference of the potential will be equal to 0. So if the electric potential difference is 0, then WAB upon Q is also equal to 0. Then WAB cross multiplication is also equal to 0. So we can say it's a really very interesting observation that we could say. If we do a work on the equipotential surface in moving a charge from one place to another place, then the work done will be equal to 0. Why? Because the potential difference on any point placed on the equipotential surface is equal to 0. That is why if the difference of the potential is 0, work done is also equal to 0, because there is no any change in the potential energy of the charge. Because there is no any change of potential energy in the charge, and the work done is also stored or considered as the potential energy, and if there is no any change in the potential energy as well as if there is no any change in potential, then the work done is also considered as a 0. So it's a really very easy to move a charge on the equipotential surface without exerting any kind of force. Let's see another characteristic based on the equipotential surface, that the direction of electric field. Direction of electric field. on equipotential surface. For example, let's take the same configuration. This one is the charge, this one is the equipotential surface, and we have to find out the direction of electric field. And from the Gaussian's law and the Gaussian's chapter, we also considered as the electric field will be perpendicular outward to the surface. This is the result which we have already observed in our previous lectures and the chapters. But today we are going to prove it by the mathematical that why electric field will always perpendicular outward to the surface, and this is also considered as in the Gaussian surface. Let's see why this is happening. As we know, the formula or the relation between electric potential and the electric field is given as del V is equal to minus integration of E dot dl. Integration of E dot dl. So if the potential difference is 0, then E dl cos theta is also equal to 0. And as we know that electric field is not 0. Why? Because there is a charge placed inside the closed surface. And dl is also not 0 because we are calculating electric field by r distance. So E is not 0, dl is not 0, but the multiplication of all the three quantities is equal to 0. It means, it indicates that cos theta must be equal to 0. Cos theta must be equal to 0. Why? Because E is not equal to 0, dl is also not equal to 0. It means cos theta must be equal to 0 to get the result as 0. So let's consider that cos theta is equal to 0. It means theta is equal to cos inverse 0. It means theta is equal to 90 degree. So as the theta is equal to 90 degree, it means that electric field always be perpendicular to the surface. Electric field always be perpendicular to the surface. Is it clear to everyone? That is the reason why electric field is always perpendicular to the surface. And this result is also considered in our previous lecture, that is Gaussian's law and the application of Gaussian's law. So moving further, on the next topic, that is the next characteristic of the equipotential surface, that two equipotential surface never intersect each other. Two equipotential surface never intersect each other. Why? This result is also observed in our last topic, that was electric field lines. We also stated that two electric field lines also never intersect each other. हमने पहले भी ये चीज देखी है कि दो electric field lines E1, E2 never intersect each other. Why? Because intersecting each other gives us a common point, and on the common point we can draw two tangents. First one based on the E1 and second one based on the E2. And the tangent shows the direction of electric field at that point. Now, if we considered it with respect to E1, we were going to say that the direction of electric field will be this one. And if we considered this point as a respect to E2, we will going to say that the direction of electric field will be something like this. But electric field cannot be in the both direction at the same time. It must be in the single direction at a particular instant of time. So here it is a contradict that which direction we have to consider. If we consider this one, then this one will be wrong for the circumstances. And if we consider this one, then it will contradict this one. So that is why two electric field lines never intersect each other. In the same way, we would say that two equipotential surfaces also never intersect each other. For example, मान लिया हमने हमारे पास एक इलेक्ट्रिक पोटेंशियल सरफेस, इक्विपोटेंशियल सरफेस जो है वो है जिस पे पोटेंशियल की वैल्यू है V1. इसके हर एक पॉइंट पे पोटेंशियल की वैल्यू कितनी है V1. एक और सरफेस है हमारे पास S2, इसके हर एक पॉइंट पे पोटेंशियल की वैल्यू कितनी है V2, इसके हर एक पॉइंट पे पोटेंशियल की वैल्यू कितनी है V2। मान लो अब अगर हम इसे क्या कराएं, इंटरसेक्ट कराएं, अगर हम इसे इंटरसेक्ट कराएं, तो जब हम इसे इंटरसेक्ट कराएंगे तो यहां पे एक कॉमन लाइन आएगी भाई, एक सरफेस ये है, एक सरफेस ये है, दोनों एक दूसरे को इंटरसेक्ट करेगी। जब दोनों एक दूसरे को इंटरसेक्ट करेगी तो उन दोनों के बीच में क्या आएगी, एक कॉमन लाइन आएगी, कॉमन लाइन ऑफ इंटरसेक्शन आएगी। अब एक बात बताइए, ये वाली सरफेस तो कह रही है कि उस लाइन पे पोटेंशियल होना चाहिए V1, लेकिन ये वाली सरफेस के रेस्पेक्ट में अगर हम देखें तो उस पे पोटेंशियल कितना होना चाहिए V2। लेकिन वो जो लाइन है वो लाइन दोनों के लिए कॉमन है, क्योंकि उस लाइन से दोनों सरफेस क्या कर रही है, एक दूसरे को इंटरसेक्ट कर रही है। इट मींस द पोटेंशियल ऑन द लाइन मस्ट बी सेम with respect to surface, but that line is common for both the different surfaces. Now it is also contradict. Which one value of potential we have to consider? So that is the reason why if we took V1 it will be wrong for the second surface, if we took V2 it will be wrong for the first surface, and even if we took ना तेरा ना मेरा, ले छोड़, V1 plus V2 by 2 एवरेज ले ले, खत्म कर, ना तेरा ना मेरा, अगर हम एवरेज भी ले लेते हैं तब भी वो गलत है, क्यों? क्योंकि जैसे हमने एवरेज लिया वो इस वाली सरफेस को भी मैच नहीं कर रहा, इस वाली सरफेस को भी मैच नहीं कर रहा। बट जबकि इक्विपोटेंशियल सरफेस की डेफिनेशन क्या होती है कि थ्रू आउट होल द सरफेस द पोटेंशियल रिमेन सेम, बट वही चीज यहाँ पे फॉलो होगी नहीं, कंडीशन फॉलो होगी नहीं। दैट इज द रीजन व्हाई टू इक्विपोटेंशियल सरफेस नेवर इंटरसेक्ट ईच अदर। सो दिस इज व्हाट ऑल अबाउट इक्विपोटेंशियल सरफेस, बेसिक डेफिनेशंस, कॉन्फिगरेशंस एंड few characteristics based on the equipotential surface.